Welcome back to another video session. In this video, I'm going to explain to you the bubble sort algorithm. Before writing the algorithm, I'll be explaining the example. From the example, we will write the algorithm. So it is very important that you understand the example which I'm going to give. In the bubble sort algorithm, the input is a random array. You can see here the elements are random. Okay. And what we will be doing in this bubble sort algorithm is we will be starting from left to right. We will be comparing two elements at a time. That means we will compare a pair of elements. For example, we will start with this and this, and we will see whether the first element is greater than the second element. If the first element is greater than the second element, we will perform the swap operation. This is one step, one basic operation. Once we do that, what we will be doing is in the next step, we will compare the next two pair of elements. That is, we will be taking this element and this element. And then once this is done, we will be taking these two elements. Once that is done, we will be taking these two elements, and based on the value of the first element, if that is greater than the second element, okay, we will do the swap operation. Once we reach the end of the array, that means once we compare these two elements, the first iteration or the first pass is over. Okay, so here I'm going to make use of these variables pass, which indicates in what iteration or in which pass you are in the current stage of the algorithm. And then there is a variable I, which is very important, which indicates you are currently in which position. For example, in our algorithm, we will be starting from position 1, and when we are at position 1, we will be considering these two elements, and then it will be incremented to 2, and when we are at this position 2, we will be considering these two elements, and so far it goes like this. Okay, and there will be another variable which is known as is swapped variable. It is a boolean variable, as the name indicates. Now what this variable does is, at any point of time during the pass, if there is any swapping takes place, this will be turned to true. Okay, before the beginning of the pass, this variable will be set to false. Okay, now this whole thing which I explained to you now will be shown through animation, which I'm going to show you in the next slide. Okay, so in the next slide, this is what we are doing. Please note the values of these three variables I just explained. The variable pass is an integer variable which is now 1, because it means that we are now going through first examination of the elements from left to right. Okay, one complete examination of pair of elements from left to right completes one pass. Okay, so now currently we are in the first pass, and there is next variable I, which is 1. That means we are now here at position 1, which means that we are comparing these two elements at a time. Okay, and before the beginning of the pass, every pass, this variable is swapped is set to false. This is a very useful variable which will actually control the execution of the loop. Okay, this will actually decide when the algorithm needs to be stopped. Okay, now this will become more clearer when we progress in this example. Now what I'm going to do is, at every point of time, I'll consider a pair of elements like this, the first two elements based on this position. If the first element, which is this one, if that is greater than the second element, I will keep on checking this condition. Okay, if that is true, what I'm going to do is I'm going to perform a swap operation. Please note that once I perform the swap operation, this variable has been changed to true. Now this will remain true until you reach the end of this pass. Okay, you can see here next is considering from position 2. You can see here the element is from position 2. Now again I do the same thing. I consider two elements at a time. Okay, now this is the first element, this is the second element. The first element, if that is greater than the second element, we will do the swapping. But here in this case, the first element is not greater than the second element, it is false. So I will not perform any swap operation. Going ahead, I now consider the element from this position, elements from this position. So that means I'll be considering these two elements now. Now I do the same thing. If the first element, which is 101 from position 2, you can see here, if that is greater than the position 3 element, which is 77, this is true in our case. If that is true, we will perform the swap operation. So when I do the swap operation, 101 has moved here, 77 has been placed here. Okay, now going ahead, now same thing applies to position 4. Now at position 4 we have these two pair of elements. Okay, so now again the first element, which is a of 3, is greater than second element, so therefore we will perform the swap operation, and it goes on like this. At position 5, again the previous element is greater than the first element is greater than the second element, so we will do the swap operation. Now this completes one pass, and the pass will end when the I value reaches the last index of the array, because going ahead will throw the exception of array index out of bounds error exception. Okay, so this completes the first pass, and what happened in the first pass is automatically the element with highest value has been moved to the last location. So now we can consider this part of the array is sorted. Okay, whereas this part of the array is not sorted yet. Okay, so what happens is, as we progress through the array, the algorithm, a part of the array will be keep on building up as sorted array until we reach the end of all the passes. Okay, so now this completes the first pass. Now how I can write a pseudocode for this based on our understanding is something like this. I'm going to the notepad here. As we all know that step 1 is getting the random array. Okay, and the step 2, what I'm going to do is I'm going to write a for loop. This for loop indicates the comparison of elements pairwise starting from position 1 all the way up to position 5. So in our example, it ended when I value reached 5. So here the value of n, which means the size of the array, is actually how much? It is 6, because there are 6 elements in our example. So I can write here, keep on doing until the value of I is less than 6, which is actually the size of the array. So if the array is a here, you can say here a dot length I plus plus, because at every time what we do is we are actually incrementing the value of I once we compare a pair of values. Now here what I'm going to do is this one. If the first element is greater than the second element, what we are doing is we are performing a swap operation. So I'm saying here do swap. Okay, now this is what we understood through the example which I demonstrated in the previous animation, or in the by the end of the first pass. This is what we understood. Okay, now going back to the algorithm here, I'll keep coming back to this to complete the pseudocode or the algorithm for bubble sorter. Now please note that this is not the complete algorithm yet, but this is the based on our understanding from pass 1 of the example. Now coming back to this one, please note that every time we perform a swap operation in the pass, that will be turned to true, and it remains true until end of the pass. Okay, so here the moment you perform swap, what you are going to do is you are making the variable is swapped to true. And if you remember, I told you before the beginning of any pass, this variable is swapped is set to false. Okay, so we can quickly see that one here. You can see here in this slide, I told you before the beginning of the pass, the variable is swapped is set to false. So that is what I'm doing it here before the beginning of the pass. This is the looping for doing one pass of examination of pair of values from left to right. I'm setting it to false. Now the moment you do a swap, this is turned true. Okay, so based on the first pass, almost 50% of our algorithm has been ready. Okay, now Let's go to our example and see how the next pass works. Okay, please note that the decision to do one more pass depends on this variable is swapped. Okay, if is swapped is turned true, okay, we will be doing one more pass. Okay, so this is the stopping condition for our algorithm. Now because is swapped is true, we will do one more pass. So going ahead here, this is pass 2. Okay, again the variable has been initialized to 1, and before we start doing any pass, this variable is made to store the value false. Okay, so we are starting from position 1. We are going to compare two elements at a time in a similar fashion as we did in pass 1. Okay, so first element is not greater than the second element, so we will not do a swap. Again the same thing here, the first element is not greater than the second element, there is no swap. Now second, this is the position of comparison. Now I equal to 3, so these are the two elements we are considering now at a time. So the first element here is indeed greater than the second element. Okay, so in this case we do the swapping. Students, here let's go and replace this words that we have written here, first element and second element, with a Java kind of statement. See here, if the value of I is 3, first element is 2, second element is 3. Okay, so please note that I value is 3, the first value index is 2, second value index is 3. Okay, so what we can do is actually for the first element we can say a of I minus 1. Okay, so inside this index we can say I minus 1. This is the first element, and a of I indicates the second element. Okay, so let's go here and replace this with a of I greater than second element. This is a of I minus 1. The second element is actually a of I. Okay, now going ahead, those two elements got swapped. I is 3, now I will be 4. You can see here I value is 4, the first element is 3, so therefore a of I minus 1, second element is a of 4, so therefore it is a of I. Now the first element is greater than the second element, we perform the swapping, and once we continue in the same fashion, we will not do swapping here because the first element is not greater than the second element. But please note that we have reached the end of the array. This completes pass number 2, but more important is to observe the variable is swapped, which is having now true, which means that we need to do one more pass. Okay, so going ahead, I'll do now the third pass. Third pass, again the I value is reset to position 1, is swapped is set to false. I'll keep on comparing two elements at a time in a similar fashion which I explained, and I'll do the swapping if there is a necessity that first element value is greater than the second element value. Here we do the swapping. Again we perform the pairwise comparison like this. At position 3 we do swapping here, and remaining pair of values need not be sorted here. Okay, so this completes now pass 3. We have reached the last position. Important to observe is swapped variable, which is again made true. That means we need to do one more pass. Okay, so this is the end of 3 passes. You can see here, by the end of 3 passes, up to this, the part of the array is sorted, but this part is not yet sorted. Okay, so 3 passes over, 3 positions in the array are already sorted. This is how the array builds its sorted version. Okay, now going ahead, because is swapped is set to true, I'll start with pass 4. I is reset to position 1, is swapped is again false. I compare the two elements pairwise in a similar fashion. I do the swapping here. Next to, again I do the swapping. No more swapping is needed. This completes pass 4. Okay, now pass 4 is complete. Important to notice this has been turned to true. Okay, so therefore there is a need to do one more pass. Okay, now this is the result of pass 4. Let's do one more pass, Pass number 5, I is reset to 1, is swapped is set to false before the beginning of any pass. Okay. Now I compare two elements at a time. I keep on doing pairwise comparison like this, and we have reached the end of the array. And what we noticed here in this pass is no pair of elements were swapped. So this variable is swapped remained false. This indicates that there is no need to perform any more passes. So therefore algorithm should stop at this point. Okay, so you can see here now the array is sorted. So going back to this algorithm now, based on our understanding, this is just doing one pass. Actually we need to perform more passes until the variable is swapped remains false. Okay, so I'm going to put a do while kind of loop here. So keep on doing all these things, that is comparing pairwise from first to last, doing different passes until is swapped is equal to false. Sorry, it's equal to true. Okay, you do the pass at any point of time. If is swapped is returned true, you do one more pass. Okay, we did all the passes and is swapped remained false. So what happens is, after we finished the passes, it will check is swapped is false. False equal true. The condition is wrong, so therefore the looping will stop. This completes the step 2, and in step 3 what we will do is we will output the array A, which is now sorted. Okay, so in the next video I will be showing you how we can write a Java code for bubble sort, and also I will give you some tips to improve the number of operations, or in other words how we can cut down on unnecessary comparisons in the next video of implementation.